Welcome to G Fun Facts Online, where we explore the biggest ideas in science. Today we're talking about a particle that changed everything. Picture this. It's July 4th, 2012. Physicists at CERN's Large Hadron Collider announced to the world they've found something. Not just anything, but a particle they'd been hunting for nearly half a century. They found the Higgs boson. This wasn't just another discovery. It was like finding the final missing piece of a grand puzzle, the one that makes the entire picture make sense. But what is it, and why does it matter so much? Imagine an invisible energy field that fills every single inch of the entire universe. This is the Higgs field. As fundamental particles, the tiny building blocks of everything, move through this field. They interact with it. Think of it like walking through water. Some particles push through easily, while others have a much harder time. This interaction, this drag, is what gives particles their mass. Particles that interact strongly become heavy, like protons, while those with weak interactions stay light. Without this mechanism, there would be no mass, no atoms, no stars, no planets, and no us. The universe would be a completely different and likely empty place. The Higgs boson is a tiny, tangible ripple in that field, the proof that it exists. Finding it was the triumphant confirmation of a theory first proposed by Peter Higgs and other physicists way back in 1964. But finding the Higgs boson wasn't the end of the story. In fact, it was just the beginning. Now that scientists know it exists, the real work has begun, getting to know it. They are meticulously studying its properties. Its mass is about 125 giga-electron volts, or roughly 130 times heavier than a proton. Uniquely, it has a spin of 0. By comparing every detail of the Higgs boson to the predictions of our current best theory, the standard model of particle physics, scientists are looking for cracks. They're searching for tiny deviations that could point to a whole new realm of physics we don't yet understand. So far, the Higgs has behaved exactly as expected. But the hunt is on for more exotic possibilities, like theories that suggest there might be multiple types of Higgs bosons. One of the most exciting new frontiers is studying how Higgs bosons interact with each other. Observing this incredibly rare process could reveal secrets about the cataclysmic events of the early universe. To do this, scientists are upgrading the Large Hadron Collider to a new superpowered version called the High Luminosity LHC, designed to produce a flood of new data. But the Higgs isn't just a particle. It's a gateway to the cosmos' deepest secrets. Its properties are bizarrely linked to the very stability of our universe. The mass we've measured suggests our universe might exist in a metastable state. This means it's stable for now, but it could, in the distant future, collapse into a lower energy state, an event that would rewrite the laws of physics and obliterate everything. And what about the biggest mystery of all? Dark matter. This enigmatic substance makes up about 27% of the universe, yet we have no idea what it is. But we know it has mass, which means it must interact with the Higgs field. Physicists are actively sifting through data from the LHC, looking for the faintest whisper of an interaction between the Higgs and dark matter, a clue that could finally reveal its identity. The legacy of the Higgs boson is more than just science. It's a story of human curiosity and global collaboration on a massive scale. It pushed our technology to its limits and inspired a new generation of scientists. The Higgs boson, once the missing piece of the puzzle, has now become our guide, leading us into a new era of exploration. It's a constant reminder that the universe is filled with wonders, and we've only just begun to uncover them. Thanks for listening to G Fun Facts Online.